Hello, good afternoon, sir. I am Vipul from Section A Big Data Analytics, and today I am going to analyze the customer churn on certain data with the help of KNIME Analytics. It is a non-coding platform which help us to analyze different type of visualization without writing a single line of code. So let's start with that. For that, we have to use Excel reader because our data is in the Excel form. Now we have to double click on it. We have to browse our data. Here it is our data. Simply we click on apply and then OK. Here we are executing it. Now you can see that these are the columns which are consisting of customer ID, churn, tenure, city tiers like that. One thing which is noticeable here is that the churn and city tier is in the integer form. We have to convert it into a string. For that, we are going to double click on the Excel reader, going to transformation. Here we are going to select string, same with city tier. Click on apply. OK. Again, we are executing that. Now you can see that the churn and city tier are in the string form. We do not need customer ID, and for that we are going to use column filter. Here it is. We can also drag and drop it here. Here it is customer ID. We have to exclude that. Now you can see that there is no column related with customer ID. And here Here there are lots of rows which consist of missing values like tenure, which have 264 missing values, warehouse to home. So there are different rows which have different number of missing value. We have to remove that, and for that we are going to use row column. So we are using row filter. We are going to drag and drop it. Here is the option for the filter criteria. As you know that the tenure consists of some missing values. So tenure and is not missing. So we can interpret it like that. If the tenure is not missing, then we can include those data in the data set. So let's apply and execute. Let's see. So here tenure is not consisting any missing values. So there are many other rows. For that we have to do that again. Warehouse to home. Now another one is our spend on app. Uh, the next one is order amount hike. Again, we have to choose is not missing. The next one is coupon used. Is not missing. Next one is order count. In operator is not missing. And the last one is day since last order. So we have total 7 rows which consist of missing values, and we want that this row do not consist of missing values so that our prediction can be smoothly done. So you can see there is no missing value in any of the rows. From here, we are going to establish a relation with pie chart where we can see that what is the ratio of the customer who are churned and who are still loyal for the company. So you can see this consistently 100%. We have to choose here occurrence count. So this portion generally tells us that 60.72 percentage of the customer are churn from the company from the e-commerce website, and 83.28% are still with that platform. So the next thing is in the line, we have to find a correlation between the variables. For that, we are going to use li linear correlation node. We are going to join it with the row filter. We have to double click. We have to double click on it. So, uh, what we can do is that we have to exclude those columns which consist some kind of text. So here we started with churn, preferred login device, city tier, preferred payment mode, gender, preferred order category, marital status. Now apply and OK. Now we are going to execute that. So here you can see that the value which are with a negative sign, it means that there is a negative correlation between these two things, first column and second column. And the p-value generally defined as that if the value is less than 0.05, then this variable have a significant impact on the model. If the value is greater than 0.05, then the feature is not such significant, so we can ignore that. So what we are doing next is we are again going to do a one to many node. We are going to connect it with the row filters, and we do this because we are doing here one hot encoding. For that, we are excluding the churn here. Huh. So you can see the things are right here. Um, Now we are again use column filter because we have to remove the duplicates value which are in the form of string. So here is our column filter. So we are going to connect it with one to many. Huh. So now we have to remove all the value except churn, because churn have to be there because this is the actual value. City tier, preferred payment gender, preferred order category, marital status. apply and execute. You can see there is no other string value. So now we now you can see there is lots of number which have a different range. Some are in the single digit, some are in the double digit. For that we are going to use normalizer. What normalizer generally do is that it makes sure that all the numbers are in the certain range so that there is no different effect if there is a bigger number or smaller number. So we are going to connect it with the normalizer and we are going to execute that. So you can see clearly that the generally the range is from 0 to 1. So it just scaling the number in that range. Now, now we have to build a model. For that we are going to have some data for the test and for the train. So we are going to use table partitioner for that. We generally connect it. You can see here 70% of the data is used for the training and the remaining 30% are used for the testing. And we are selecting stratified so that from all the category our data is selected for training. Apply and execute. So here it is done. And now we are for the model we are going to use logistic learner so that our model can learn with this 70% of the data. Here the target column is shown. We have to select one. One because the customer who churned the company. So the next one is logistic regression predictor. Uh, Here we have to take both the options, apply and OK. Now how it is here you can see that there is a predicted value 0 for those who are still using the e-commerce website and 1 for those who are churn. Now we have to check if what is the accuracy of this model. For that we are going to use scorer. It generally tells us what is the percentage of accuracy we can achieve with this model. Here we have to select the actual churn, apply and OK. Mhm. So here you can see that this is a confusion matrix. 106 is the true positive value and 83 is the false negative. 37 again the false positive and 907 is the true negative. For the accuracy, you can see that 89.4 percentage. We can say that it is a good accuracy number we can achieve. This is generally for the logistic regression. We can also use decision tree for that. For the decision tree model, we need again to divide the data set. For that, we are going to use table partitioner. Here it is. Um, we can for like this is the random tree forest, so we can here avoid the stratified. We are simply going with random and executing it. So 70% of the data are used for the training and 30% used for the testing. Now We are going to use decision tree learner. Decision tree learner, and we have to predict churn. So selecting churn. Here we have to keep node to 20, number of threads, keep it 8. Now apply and okay. So next thing is predictor. So we have to select the both options, apply and okay. Now we are executing it. For the accuracy part, we need a scorer so that it can tell us what is the accuracy score for this model. Here it is connected. We have to select churn here as this is the actual column and the predicted churn is the predicted column. Apply okay. Execute. We executed that. So here you can see that there is slightly a change because we do not use the stratified sampling. For accuracy, we generally see the accuracy is still slightly better than the first one, 89.1%. So we can say that decision tree is slightly better than the logistic regression model. So here it is, we actually predicted the confusion matrix with both the decision tree as well as the logistic predictor. So here this is the confusion matrix. So thank you, sir, from the my side.